Here's a third example on simplifying complex fractions. So again, I'm going to work through this one both ways. I want you to try and practice both. You don't have to do both on every problem, but maybe bounce back and forth a little to see what happens. So method number 1 says perform the addition and subtraction first. So follow order of operations. Perform the operations in the parentheses and then perform the division. So we will need a common denominator for 1 minus 4x squared, and that is going to have to be x squared. So we'll multiply the 1 by x squared over x squared. X squared over x squared minus 4 over x squared. On the bottom, it looks like the LCD is going to be x squared again. If we just multiply the top and bottom of 2x by x, we'll have a common denominator. So 2x over x squared plus 8 over x squared. Okay, so now we can go ahead and subtract x squared minus 4 over x squared divided by 2x plus 8 over x squared. Dividing fractions means flip and multiply. X plus 8. Okay, so x squareds. And I'm looking at this so we can reduce by canceling the x squareds. We can also factor. So I'm going to go ahead and do some of this work here. We have a difference of squares, x plus 2, x minus 2. And then on the bottom, oh, it doesn't look like it's actually going to work out anyways. I was hoping it's going to be an x plus 4. So no luck. I was thinking I was going to get to cancel one piece out of that, but it looks like we'll just keep it. So you can either write it factored or not factored. I don't really care. I'll put it back how it was. The purpose of factoring is to cancel. So if you're not getting anything canceled, you don't have to do that. In fact, if you can tell right away it's not going to cancel, then don't bother trying to factor at all. Okay, so there's method number 1. Perform the addition, subtraction separately, and then perform the division. Method number 2 says go back to where you started, and instead of building a common denominator within the big fraction, just wipe out all the fractions within the big fraction. So we're going to say our common denominator for top and bottom, sorry, just trying to get a hair off, and I'm probably making you dizzy, is x squared. And then again, don't forget your grouping symbol. That's the key. That's the thing that people mess up once they get going on this method. People are generally pretty good, but they'll forget to distribute, especially when there's something like that 1 floating around where you're not thinking, I have to cancel the denominator. People generally recognize if they forgot to multiply a fraction and they still have denominators, but the 1 they'll forget about. So 1 times x squared is x squared. Negative 4 over x squared times x squared is minus 4, negative 4. On the bottom, x squared times 2 over x, we get to cancel one of those x's and we get a 2x. And then 8 over x squared times x squared is just 8. And we've already checked to see if we can reduce that, so I think we're in good shape with that one. Okay, let's do one more in this one. Getting a little bit messier. But again, like I said, one of the themes is seeing the simpler problem. So all of these look messy. This one will look particularly bad to people, but it's really very similar to the last one. Just because our denominator now has an x plus 1 in it doesn't mean that our approach is really any different. So method 1 is going to be looking at the top. The denominator, common denominator, is going to be x plus 1. So we'll multiply this by x plus 1 over x plus 1. And we'll get x plus 1 over x plus 1 plus 1 over x plus 1. On the bottom, common denominator also x plus 1. So the first fraction is fine. The second one will multiply top and bottom by x plus 1. Oops, no 4. Over x plus 1. You can multiply the 4 in if you'd like to. In fact, I think I'm going to. 4x plus 4. Okay, so now we go ahead and we do the addition in the top. So we'll have x plus 1, which is x plus 2, divided by x plus 1, over x squared plus 4x plus 4, divided by x plus 1. Okay, so then we'll flip and multiply x plus 2 over x plus 1 times x plus 1 over, I don't need a parenthesis right now, I'm thinking about factoring already, x squared plus 4x plus 4. Okay, so the x plus 1's cancel. That's very nice. And I am looking at that x squared plus 4x plus 4 and seeing that that's actually really nice. It factors into x plus 2 times x plus 2, which is x plus 2 squared. So we also get to cancel an x plus 2. Remember that when you do that, there's still a 1. So it's not that everything is gone and the x plus 2 moves up. The x plus 2 is still in the denominator. Let me cross that one out for myself too. And now there's only a 1 left in the top. Okay, so method number 1. Method number 2, instead of getting each fraction to have the same denominator, I'm just going to jump straight to eliminating the denominators. So I'm going to multiply the top by x plus 1. I'm going to multiply the bottom by x plus 1. I'm not going to forget about the grouping. And in fact, I'm going to mentally group this together because this might look a little funny. So I'm distributing an x plus 1 through. When I multiply x plus 1 by 1, I get x plus 1. When I multiply x plus 1 by 1 over x plus 1, I get x plus 1 over x plus 1, which is just 1. On the bottom, again, I'm going to mentally block that together. I'm distributing x plus 1 in. X plus 1 times x squared over x plus 1. I get to cancel the x plus 1's. Just an x squared is left. When I multiply 4 by x plus 1, nothing cancels. I get a 4x plus 4, which looks very familiar. X plus 2 over x plus 2 squared equals 1 over x plus 2. Okay, thanks for watching.